Hello students, this is Mr. Nguyen. Today we're going to be learning how to solve equations that produce solutions. So the equations we're going to be looking at today are going to be two-step equations, multi-step equations with variables on both sides, and multi-step equations with using the distributive properties. And so all of the equations we're going to be looking at today are going to have a solution. That means whatever variable we're solving for, it's going to have a value at the end. Okay. Most equations that we study in algebra contain variables, right? So the variables are the letter like x, y, z, m, n. Okay, and these letters represent a specific numbers. And so the equations we're going to solve today are going to have answers, are going to have actual numbers that go with them. Okay. So for example, in this equation, 4x plus 7 equals 19, the x is the variable, right? And we're going to talk about the structure of these equations later. So the x represent what we don't know, right? It's the unknown. It's the value that we don't know. It's the value that is going to make that left side of the equation equals to 19, right? And we're going to use inverse operations to sort of go back and find what x is. Okay. So that's our goal. Our goal is to find the value that makes this equation true. And the process of finding this is called solving the equation, right? All right, here's the take a look at the structure of a typical equation. So a typical equation have a variable, a coefficient, an operator, and some constants, right? So coefficient is the number that stands right in front of the variable. And the operator, now here it's pointing to this minus sign being the operator, but we have to know that there is another operation going on here. It's 4 times x, right? So keep that in mind. And then, of course, there is an equal sign because it is an equation. It's telling you that the left-hand side over here, it's equal to the right-hand side with some value of x that is going to make that true. Okay, so there is a value of x that when you put it in here, all of this is going to equal to 5. Okay, so we're going to learn how to find that value. Okay. So to with this given equation, to solve for h, we're going to have to what we do is we have to make sure that the variable is on one side of the equation and all of the constants need to be on the other side. Okay. So let's see how we're going to do this. Okay. So first, the best thing to do is to, because we are getting h by itself, the best thing to do is to get rid of 12 first, because 12 is kind of like separated from h, so it's the easiest thing to remove, right? So we're going to be doing something to get rid of that 12. Well, we're going to be using inverse operation to undo this plus. So we're going to be subtracting 12 from both sides. Okay. So we subtract 12 from both sides. So this is going to simplify to nothing, right? And then all we have is h over 3 over here on the left hand side. And over here, because we are subtracting 12 on both sides, the 16 minus 12 is going to need to be simplified down to 4. So on the left hand side, we have h plus 3 equals to 4. So as you can see, we started out with a pretty sort of long equation, and then we tried to simplify it down to something shorter. And that's the goal, is to get the equation shorter and shorter and shorter each time until the variable is completely by itself. Okay, so here we have one more step. We have to get rid of this 3 at the bottom. Well, this is division, and so we have to use inverse operation, which is multiplication, to get rid of that. So we're going to be multiplying both sides by 3. Okay, and then of course we're going to simplify again. We're going to simplify this side to, so the 3 and the 3 will go away, because 3 divided by 3 is 1. So we have 1 h left. And then on the other side, we have 4 times 3, which is 12. And this is a solution. So what this is saying is, hey, we reversed everything and we got down to 12. And so we're saying h has to be 12 in order for all of this to equal to 16. That's what the solution means. Okay. All right, before we go on further, let's take a brain break. Okay, let's ask ourselves this. Would you rather have a chance to explore space or get an opportunity to explore the ocean? Hmm. This is a hard one for me. I think I would do the. I'm kind of scared of both. I don't know. I'm kind of scared of both. They say that if you go out in space and you look back on Earth and you look at all the other planets, um, it's really beautiful. But then I can also see that it might be lonely in space. So I think I might pick the ocean first because it's closer to home. But both are really good. All right, let's get back to math here. All right, this is your turn to tell me the two inverse operations that we would need in order to reverse all of these in order to get z by itself. So if I were doing this live with you, you would be typing in your response, right? So I hope that you would type in the inverse operation for -1 would be addition, and then the inverse operation for dividing by 3 would be multiplication. So the two inverse operation we would use here would be addition and multiplication in order to undo these two numbers in order for z to be by itself, okay? All right, next one is the given value a solution to the equation? Okay, so sometime they give you some values that they say, hey, this may be the answer to this solution. Let's check it out to see if that's true. And this is a very useful skill because sometime when you get an answer to your problem, you want to check to see if that answer actually works, right? So what do? Well, we're going to work on the left-hand side here. And the left hand side is 7x minus 4. And what we do is we take this 3 that they said x was, and we substitute it in where x is. So we put x in where, 3 in where x is. So this becomes 7 times 3 minus 4. Well, 7 times 3 is 21. 21 minus 4 is 17. So now that's the left hand side. It's equal to 17. We want to also check the right hand side. Okay, so we're going to check the right hand side in the same way we checked the left hand side. We substitute 3 in here, so 3 times 3 is 9, and then plus 8. Well, 9 plus 8 is 17. Well, now we know the left hand side is equal to the right hand side, which means this equation is true when x is 3. So therefore, x has to be the solution. Okay, so x has to be the solution because we just verify that the left-hand side is equal to the right-hand side, which is a true statement. Okay, remember, a solution needs to make the statement true. Okay, all right, this time you do it. Okay, you use what I just did there. Get a piece of paper out and write down. If you were doing this live with me, I would have you do this with me. But since you were watching this video, now we're going to talk about it, right? We're going to put 1 in here, right? We're going to substitute 1 in here. Well, this time you really just have the right-hand side to check because the left-hand side is already 3. So we're going to put 1 in here. Well, 2 times 1 is 2, plus 3 is 5. So the left-hand side is 3, but the right-hand side is 5. So your conclusion should be what? It is not a solution because 3 is not equal to 5 because you end up with a false statement. That's why x equals to 1 cannot be the solution, right? The solution has to work, okay? And it doesn't work in this case. All right, this is for you also. Okay, think about inverse operations that we just did earlier. For this equation, which would you choose? Okay, so to get s by itself, you have to remove the minus 19 and remove the division by 4. So to remove the minus, you have to add. To remove the division, you have to multiply. So the two operations, the inverses, no, there should not be an S here. The two inverse operations we would use would be addition and multiplication. So choice C would be the correct choice, okay? All right, let's take a look at how we solve this, okay? So we said the two inverse operations were adding and multiplying, right? So the first thing we're going to be doing is adding. But what are we adding? Well, we're adding 19 to get rid of it, right? So in order to get that 19 to the other side, we're doing the inverse operation. Okay, so we're adding 19 to both sides. And of course, we're going to simplify to make our equation shorter, right? So this side, the 19 and the negative 19 just sort of zero out. And then the s divided by 4 stays. And then here, the negative 15 plus 19 is 4. And now one more step to get rid of this 4. So we said it was multiplication. So we have to multiply both sides by 4. And then we're going to simplify again. And then we get s equals to 16. Okay? All right, let's take a look at this one. You're going to be doing this one on your own. And then you're going to tell me what your solution is when you get it. Okay? So in here, I would so the 4j, it's stuck together. The easiest one to remove is the positive 2 here. To remove a positive 2, you have to do a negative 2 on the other side. So you're virtually subtracting 2, right? We're subtracting 2, so 18 minus 2, okay? And that would give you 16. And then finally, to undo this 4, because it is multiplication, we're going to use inverse of that, which is division. So we're going to take 16 and we're going to divide by 4. So your answer should have been C if you did this by yourself. Okay. All right. So here's exactly what I just said worked out for you. So if you did something wrong on the last slide, make sure you check your work with this slide. Okay. All right, distributive property. Okay, sometimes the equation gets crazy and there's parentheses in there. Okay, so whenever you see parentheses, that means you have to use the distributive property to simplify the equation first and then solve it. Okay, so if you were to distribute this 2, what would your equation look like? So take a minute and try that on your own. So if I were to do this, I would leave the 4x alone first, and I would take care of this 2. I would multiply the 2 through wherever the parentheses are, right? Don't multiply the 2 with everything, okay? Just do 2. And don't forget, the 2 is multiplied by the negative 6 as well. That will give you negative 12. So look over here, which one has negative 12? It's choice C. Choice C is the correct choice, okay? Choice A, they forgot to multiply 2 through. Choice B, they messed up completely. The sign is wrong. Choice C is correct. Choice D, they didn't even bother with the 6. So yeah, choice D is very wrong. Okay. All right, this one you try also. What would you do first? So think about this equation. What would you do first? This is a long equation, okay? There are 4 choices here. If you were doing this live with me, I would have you drag your little pointer here to the box that you think might be correct. Well, I'm going to let you know there are 2 correct answers. Or actually, all of these are actually correct, but only 2 of them are actually useful. The other 2 are not useful. The other 2 is just going to create more mess for you, okay? So let's take a look at this first one. Subtract 7 from both sides. So if I subtract 7 from over here and I subtract 7 over here, I would remove this positive 7. So that's actually useful, right? So this is correct. So subtract 7 from both sides are actually correct. All right, let's take a look at distribute 5 to simplify. So if I were to go ahead and distribute this 5 through, I would get rid of the parentheses, and I actually would be able to simplify the left-hand side of my equation. And so distributing 5 would also be a correct first step, right? A useful correct first step. So both of these choices are good. Let's take a look at dividing by 5. If you divide by 5 on both sides, that's by the whole equation. So you have to divide by 5 here, divide by 5 with the 7, divide by 5 with the 127. Well, if you know anything about compatible numbers, 7 divided by 5 is not going to give you a nice number. 127 divided by 5 is not going to give you a nice number. So dividing by 5, it's actually going to get us into a bigger mess and not a simplified version, right? Remember, we want to simplify the equation so that we could actually solve, right? And so we don't want to do anything that would be counterproductive, which means it makes it more messy instead of simple. Okay. All right. Let's take a look at adding 7 to both sides. Well, if I add 7 to this side, I would gain 14. So I didn't get rid of it. I actually gained more. If I add 7 to this side, I would make this number bigger, right? So it's legal to do. I mean, in math, you can do whatever you want to both sides of your equation as long as you do the same operation. But some things are more helpful than other, right? So adding 7 to both sides would not be helpful in this case, okay? So only the first two choices are actually good to do. All right, let's talk about equivalent equation. Equivalent equation is when you simplify your equations and get another version, okay? So those are all equivalent, okay? Equivalent means it's the same, it just looks different, okay? So here I would distribute this 4 through both of these, so I get 4x plus 8 equals to 3. So it's the first choice is the correct one, okay? The second choice equals to 12. I'm pretty sure they multiply this 4 all the way over here, which is incorrect, okay? You can't cross the equal sign like that. All right, next. Ooh, this is let's take a look at this problem, see why it's such a mess here. So I have 3x and then plus 15 and minus 9, and then over here I have 2 times. So I have distributive property and I have variables on both sides, right? And I have stuff here that should be simplified. So let's just talk about simplifying this equation. I would combine these two, right? And then I would multiply the 2 through just to make my equation simple, okay? So let's do that. So we're going to distribute the 2 through first, okay? Just to get rid of that. You could actually do this step all at once if you want, but I want to break it down one at a time. That way you don't get confused, okay? So we're going to multiply that 2 through. We get 2 times x and then 2 times 2, okay? And then we simplify that. We're going to get, over here we get 2x plus 4. And here I'm getting ready to simplify these two numbers. So positive 15 minus 9 would give me 6, right? So I'm simplifying everything. I combine like term right here to get 6. And now I end up with this much shorter equation than the original, right? So that's the goal. We want to get our equation shorter and shorter and shorter. Now here we have two choices. We could subtract 3x to move it over here, or we could subtract 2x and move it over here. What do you think we should do? I subtracted 2x. All right, now you might think that, oh, well, the x needs to be over here, so yeah, you move 2x over. That's a good reason, but the main reason really is to get rid of the smaller variable first, okay? So if 2x was on the left side, I would still move it to the right side, okay? So move the smaller variable. Why? Because you're going to end up with a positive variable always, okay? So anyway, 3x take away 2x give you 1x plus 6 equals to 4. Now we're going to subtract 6 from both sides, and then we're going to end up with negative 2 when we simplify this equation, okay? So the value for x is negative 2. All right, so the equations could get long. Just follow step by step. Distribute, combine like terms, move things around using inverses operations, okay? All right, let's check out this one. Get a piece of paper out and try this on your own. You can pause the video and then we'll work through it, okay? So what do we do here? We first distribute, right? And then we combine like terms, and then we move all the numbers to the right-hand side, and then we divide by 10 finally, right? Okay, so we're gonna get 10h plus 10 minus 4, and then we get, we add 4 to the other side. Oh, well, actually we combine like term because the 10 and the minus 4 gives you 6. So positive 6, so we subtract, oh, so this becomes 70, and then we divide by 10. What's 70 divided by 10 is 7. So the answer should be H, okay, if you work that out correctly. This one, oh, this one is a long one too. Distributive property, combined like term, variable on both sides. So let's take a look at this. We have 6 times 6 is 36 plus 36 minus 5 equals 1 plus 6x. And then we take 36, we subtract 5, we get 31, right? And then here we have 36x. And then we subtract the 6x to get 30x. And then we subtract the 30, or actually Yeah, 36 minus 5 is 31 actually. We subtract the 31 with the positive 1, we get negative 30. And then negative 30 divided by 30 is negative 1. So the answer to this problem should be negative 1. Okay? If you work that out correctly on your paper, the answer should be negative 1. All right, let's summarize what we have done today. Today we learned how to solve linear equations in one variable. In one variable just means there's only one type of variable, like an x, a y, a z. Okay, there's no multiple variables. So what do? We first have to use distributive property if you see parentheses, right? To remove the parentheses. Sometimes you don't have any, so you don't have to do that. And then you have to combine like terms, okay? If there are like terms on each side of the equations, you have to combine them just to make your equation shorter, okay? Then we use what we call inverse operation. If we add something to both sides, we add something to. If we're going to do subtraction, we have to subtract on both sides. And then we can do inverse operations on multiplication or division. So if we multiply something on both sides, we have to multiply. We have to multiply on one side. We need to multiply on the other side to remove sort of what we don't want. Okay. And then if you have time, take that value and plug it back into your original equation to check your answer. Okay, check your answer. And here is your independent practice assignment. I have two practice for you to do. One of them is solving two-step, and one of them is multi-step with variables on both sides. And I think the second one has distributive properties. Okay, so the first one is just to get you to warm up. They're pretty easy. The second one is the one that's a little bit more challenging. It's not too bad though. Okay, so try them out. Let me know what you how you do, or if you have any questions, you can email me your question. Just screenshot the problems. Thank you for watching. Hey, if you don't mind, click subscribe down here for me, and you'll be seeing more of these videos in the future. Thank you so much for watching. Have a great day. Bye bye.